Welcome to BSpice. In this session, once again, we'll continue with metering system BSpice member question and answer. In part 3, we'll focus on flow control valve and turbine flow meter requirements. So basically, there are three questions actually in this part, in this subject, posted by our BSpice member. That's why we are supporting him. Okay. So where should the flow control valve located in the skid? That is the first question. Okay. So, friend, the flow control valve should be installed downstream of the turbine flow meter. Why? What is the reason? Yes, if we install at the downstream of the turbine flow meter, after the flow meter, downstream, okay, it ensures stable flow condition through the turbine meter, okay, then prevents the flow disturbances like, turbulence or pulsation, whatever is there that can affect the meter accuracy, right? So it maintains a positive back pressure, which is very, very critical for preventing cavitation, okay. So these are the answers. Flow control valve should be installed at the downstream. Okay, right. Then the 6B, minimum back pressure for turbine flow meter. Your question is, what is the minimum back pressure required for the safe operation of turbine flow meter to prevent cavitation? Okay, right. So to prevent cavitation, okay, and ensure accurate measurement, the minimum back pressure, there is a formula actually, but I don't want you to, get confused with this. It is like, P back greater than or equal to 2 multiplied by delta P plus 1.25 multiplied by P vapor P back greater than 2 multiplied by delta P plus 1.5 multiplied by P vapor. So that is why, this is a bit of a what do you call theory actually. But what I suggest is you take this first, this is just for reference, maintain a back pressure of greater than or equal to 1.5 to 2 bar G above vapor pressure for most of the liquid hydrocarbon. I'm not sure which product you are using your metering skid, but for the hydrocarbon, this is the criteria. Okay, but I suggest you refer to this API MPMS chapter 5.3 in specific and manufacturer guideline for exact value. Okay, otherwise you can use that formula. I repeat the formula again: P back M greater than 2 multiplied by delta P, that is a pressure drop across the meter, plus 1.25 times P vapor P backup. P vapor means vapor pressure of the fluid at operating temperature. Then greater than or equal to 2 multiplied by delta P plus 1.5 times P vapor. Okay, this is a bit of a tricky, but my suggestion, you follow this if it is a liquid, most of the liquid hydrocarbon. Alternatively, you go with this, what do you call this chapter, APA MPMS chapter 5.3. Okay, so that is the one. Okay, then the third is 6C. Can the stream flow control valve used for proving? Okay, stream flow, the stream flow control valve. Yes, but with some conditions actually. Okay, the same FCV can be used for flow control during proving, provided it can maintain a stable and repeatable flow rate within the proving range. So that we need to watch out for. Okay. Then also it is responsive and precise enough, good enough to avoid flow fluctuation during the prover run. Then third, the flow rate during proving is within the acceptable range for both the meter and prover. So these conditions are there, then you can use this, friends. Okay. If you ensure this condition, you can use this. So this is the one. But, if you ask me the best practice, use a dedicated control loop or proving mode in flow computer to manage the FCV during proving. Okay, use a dedicated control loop. Some system use a separate proving control valve. What for? To enhance accuracy and stability. Okay, so that is the best practice. But if not possible, you can use this. Right, provided you have to meet these conditions. Okay. So that is about the 6. Okay, now we go into the 7. 7 also there are two questions. This is about the stream proving in multi-stream skid. Okay, the first question, during proving of one of the metering stream, how do the remaining streams operate? That is the question actually. Okay. In a multi-stream metering skid, stream proving is very critical, right? So that must be carefully managed. What for? To ensure the continuous and accurate custody transfer. Okay. So let's see how it's actually, operation of the remaining stream during proving. Okay. One is the active stream proving, right? So the stream selected for proving is temporarily isolated from the custody transfer. So that operation we need to do. Okay. I again repeat, friend, operation of remaining stream during proving. So one is the active stream proving, right? So the stream selected for proving is temporarily isolated from custody transfer. Okay. So that the flow is diverted through the prover loop. Okay. So the flow computer switches to proving mode for that stream, active stream. Okay. Then other stream remain in operation. How? All non-proving stream continue normal custody transfer operation. Okay. So their flow meters remain active, continuously sending data to the flow computer and SCADA. So no interruption in overall metering system output. Okay. So this is how we need to do. And in case if there is a float redistribution, if the proving stream was continuously, if the proving stream was contributing significantly to the total flow, the system may redistribute the flow across the remaining stream to maintain the throughput. Okay. Anyway, this is option only if required. So first, what my suggestion is, you focus on this. So operation of remaining stream during proving. So one is the active stream proving. Okay. So that stream selected for that proving is temporarily isolated from custody transfer. Flow is diverted to the prover loop. Then the flow computer switches to the proving mode for that stream. Then other stream all actually, continues to do the normal custody transfer. The flow meter remain active and continuously sending data to the flow computer and SCADA. No interruption. Okay. So that is the operation, what you call, during the proving of one of the metering stream, the other streams operation, other stream, how the other stream operates. So that is the, what you call, methodology. Okay. Now we go into 7B. Okay. 7B, the same extension of this earlier question. So what is the general philosophy for seamless operation? Okay. See, multi-stream skid, um, general philosophy means you need to have a isolation and interlock, right? So isolation and interlock means proving stream is isolated using automated valve. Interlock prevent the simultaneous proving and custody transfer on the same stream, right? So one is the aspect is isolation interlock. Then second is the flow computer coordination. So flow computer coordination in the sense of flow computer switches the stream to the proving mode. So the applies meter factor, updates post proving, then maintains the custody transfer data integrity for other stream. So basically isolation and interlock, then flow computer coordination. Then not only that, SCADA integration also, the SCADA displays proving status, active stream and flow rates, logs proving events and also the updates meter factor. So it allows manual override if needed. So this SCADA integration also needed. Then alarm and safety logic. Alarm for proving failure or valve malfunction or flow imbalance, all these alarm to be notified. And also the fail-safe logic ensures proving does not affect any custody transfer accuracy. So that is also there. Then proving scheduling. Proving is scheduled during low demand period. So that is the main important point actually. Proving we need to schedule during low demand period or automatically triggered based on the runtime volume or time interval. Okay. See, maybe I don't know whether you got it. See, for example, consider a scenario. Stream A is selected for proving. Okay. Now stream B and C continuously doing the custody transfer. Okay. So the flow computer logs proving data for stream A and update its meter factor. And SCADA shows stream A in proving mode, right? And streams B and C in active mode. That's it. So that is how it works actually. When we talk about the example actually. Okay. 7B done. Now we go with the question 8. If one of our project, the main line is 14-inch, reduced to 8-inch for the turbine flow meter, which with 10D upstream and 5D downstream, then expanded to 14. So this is the question actually, not a question, this is a scenario. So the question is, can we install the pressure transmitter and TT after the 5D downstream section line, 8 itself, 8 line, and the density meter must be installed after the expander in the 14-inch line. Okay, is this causes any error during calculation? Okay, so the answer, in fact, this is a very good question actually. Friends, PT and TT. Okay, so location after 5D downstream in 8-inch is okay. We can accept it. Okay, so yes, so no issues actually. But what we have to do is we need to ensure there is no flow disturbances. So no flow disturbances in the sense elbows, valves should not be there immediately downstream. And of course, good thermal contact and pressure tapping that should be there. We need to take note. But the catch point is here, density meter after expander. Okay. So basically, friends, if the density meter um, after the expander can introduce errors, what kind of error? Flow profile distortion, potential phase changes, and also non-representative sampling. So these are some of the challenges if you install the density meter after expander. So the best practice is install the density meter in the same pipe diameter and close to the turbine meter, ideally after 5D downstream, but before any diameter change. Okay. So, but if really not possible, expansion is unavoidable. You said 14-inch, right? If that is unavoidable, what we can do? We have to ensure that the straight run after expander, at least 5D is available, and the flow should be stable and pressure. Yeah, all these we need to ensure it, friends. So that's all I have for this continuous 3 sessions actually. Friend, any question you can still can reach me through this mail. I'm willing to support. Okay. Thank you, and I hope I have clarified your queries. And thanks for your membership support also. And if anything, not only metering, anything you can write to me. Not only for you, any of our BSpice members can approach me actually. Okay. Yeah. Anytime, any point of time. Thank you. Take care. Bye bye.